In this video, we are going to talk about what scientific notation is and what it's good for, as well as how to convert from what's called a standard notation number, so a number like you're used to seeing, into scientific notation. It's no sweat and it's cool stuff. Let's jump into it. So scientific notation is a way that we can notate numbers or express numbers that is more useful in science, hence the name. It's used for being able to describe really, really large numbers or really, really small numbers that have lots of digits in a much more, well, condensed manner. It makes calculations easier. So I've got a word problem for you that will give you a brief example of that, but first I need to define for you what is scientific notation. Well, scientific notation is any number times a power of 10. But that any number A needs to be between 1, including 1, but less than 10. So it can be like a number like 5.67, but it can't be 10 or more, and it certainly cannot be less than 1, like 0.278. So I've got a couple of examples over here, or just over my shoulder. These are two examples of numbers in scientific notation. 6.7 times 10 to the negative third power. When you multiply by a negative power, that's like multiplying by 1 over 10 cubed. So that's going to make this number smaller, right? Multiplying by 1/1000th. This is 1.179. This number is greater than 1 but less than 10. And remember, you could be equal to 1, that's okay. Times 10 to the 6th power. So this fits this description of scientific notation. Times 10 to the 6th is multiplying by 1,000,000, 1 with 6 zeros. These are examples of numbers not in scientific notation. You'll notice that both of the numbers being multiplied by the powers of 10, 16.73, that one's greater than 10, and 0.8257, that one is less than 1, that makes them not in scientific notation. It's as simple as that. So we have our standard rules that we use for scientific notation, and it makes bigger number math much easier. For instance, if you have that the moon is about 380 million meters from the Earth, and our goal is to convert each number into scientific notation. Well, let's say you're multiplying 380 million by the number 582. 380 million has 9 digits to it. If we write it in scientific notation, we can do the operation with many less digits. So many fewer digits, I should say. So if we take a look at this number, how do we convert it? It's very simple. We're going to make this number into a decimal between 1 and 10, and then we're going to multiply by a power of 10 to balance out the division that went on. Let me show you what I mean. So to make this a decimal between 1 and 10, we'd have to move the decimal point, and there's a decimal point right there. Here, I'll move the units. There's a decimal point right there. It's technically 380 million.0, right? So I'd have to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8 places. So that gives me 3.8. By moving the decimal point 8 places to the left, what I have done is I have divided this number by 10 to the 8th power, right? 8 different spots of multiples of 10. I've weakened this number, lessened it, divided it by 10 to the 8th power. Well, I can't just divide a number by 10 to the 8th power and say it's the same number without then balancing it and multiplying by that same value. So you've made it smaller by a factor of 10 to the 8th, then you have to at the same time multiply by 10 to the 8th. So that's what happens. When you move your decimal point to the left, making a number smaller, you must then multiply by that exact number of decimal places raised to that power, giving you that number of decimal places. That's sweet. We'll practice another one. 875,000. We have a decimal point here. Move it 1, 2, 3, 4, 5. I know to stop there because 8.75 is a number between 1, including 1, and less than 10. So that's going to be equal to 8.75. But how many places how many different places did we move the decimal point? That was tongue twister. Well, we moved the decimal places 1, 2, 3, 4, 5 times. So we lessened this number, we divided it down by 5 powers of 10. Okay, so then I've got to multiply by 5 powers of 10. And so this number is equivalent to 875,000. It's 8.75 times 10,000. Okay. Now we look at numbers 3 and number 4. We're going to go in the opposite direction here. We need to make this decimal into a value that is between 1, including 1, but less than 10. To do that, I'd have to move the decimal place 1, 2, 3, 4 places to the right. Well, that's going to equal out to 2.7. So now we've got our decimal between 1 and 10. However, we've made this number many more times bigger than it originally was. This is a very small value. So I move it 1, 2, 3, 4 times. That means that I just multiplied by 10,000, or 10 to the fourth. So I've got to divide by 10 to the fourth. Another way of dividing is by multiplying by 10 to the negative power. 10 to the negative fourth. That's the same as doing 1 over 10 to the fourth. It's just a little easier to write it with negative exponents. So if you make a number larger than it originally was, you've got to then multiply it by a base 10 power to the negative number of places that you've made the number bigger by, because, well, you've got to shrink it back down to size. At the end of the day, when we multiply this out, it's got to be equal to this. Last but certainly not least, we're going to exercise the same idea. We want to make this into a decimal between 1 and 10. We go over 1, 2, 3, 4, 5, and 6 places. So we now have the number 3.8, but we've made this very, very, very tiny number into a much bigger number. So we can't just make it a much bigger number. Like, I wish I could go to the bank and say, here's $1, let's multiply it by 1,000,000. They're going to be like, no, only if you then divide it by 1,000,000 to even it out. So same thing here. We just brought this up by a factor of 10 to the sixth, so we've got to bring it back down by that same factor. So 10 to the negative sixth. So again, the moral of the story is this, folks. If you are lessening a number by a certain power of 10, you then multiply that number by that same power of 10 that you weakened it by. If you are growing a number larger by a power of 10, you then need to multiply it by that same base power of 10, but to the opposite power, essentially saying we would move the decimal point back over 4 places, and that gives us an equivalent answer. Scientific notation, it's more than just memorizing what to do. It's understanding why it works, and that will have you on a road to success with it.